Okay, so question 17, looking at a critical angle problem, so sort of balancing, and just a couple updates to this printed slide. This is orientation A here, so the box is a width W and height 3W, so it's sort of referencing orientation A, and then this is orientation B. So what we're stating here in the question at the box below, so I would label sort of this as a width W and a height 3W. So that means over here we have a sort of a width now of 3W and a height of W for orientation B. Just adding those details. Okay, so then in this problem, looking for the critical angle. So the critical angle is given as a tan inverse of half the track width divided by the height from the base of the object to the center of gravity. And that's what we're looking for in this question. So sort of to give you there's an additional piece of sort of information. You can draw a separate diagram for to just highlight what this critical angle is referring to. So we think about when this let's say in box A or in orientation A, when we're thinking about when it might tip over. So if I were to draw the box like this, thinking to where its center of gravity might be, but here, draw this perfectly accurately, but here. So you want the center of gravity over the tipping point. So so we have a sort of triangle here, where this is H here, and we're looking for this angle in here is theta, but that's also this angle in here is theta, and that's sort of the tipping angle. And if we refer to half the base of this is the width, it's called the track width, T. Then theta again is looking at the tan inverse of the opposite. So opposite would be half of T divided by H, which is the adjacent side to this angle. That's where the equation comes from. So for orientation A, so maybe I'll write this separately. So orientation A, we have the T in this example would be would be W, sorry. So the track width is the width of the actual object, and then H would be half that, in a sense, assuming that it's a uniform box. And maybe I should update the question. You know, say that the boxes have their mass uniformly distributed, and will be located here in the center. So here, so this is our H, which is half the height. So half of 1/2 of 3W, so it's 3/2 of W, or 1.5 W's. And then for case B, our T will be now 3W, and our in this particular case we have our height here in the bottom. This is our H, and that'll be half of W. So 1/2 of W. And we're looking for the ratio of the critical angle in orientation A to that in orientation B. So I'm looking for theta C over theta B, sorry, theta C for orientation A, so the small subscript C here, looking for critical angles. We're then doing a tan inverse, so it'll be half of the track width for KC was half of W, divided by the H, which is 3/2 of W, and then all divided by the tan inverse for B. This is half of 3W divided by 1/2 of the H in this example is 1/2 of W. So we can cancel out here the factors of W, and the halves will cancel out here, and these twos will also cancel. So I have the tan inverse of 1/3 over the tan inverse of 3, which should give you 0.26. So there should be a 6 here, and choice C is the correct answer.